Hey guys, I just made a video for you and I just watched it and it's a snore. It's so boring, it's long, it's boring. I'm just going to get right down to it and I'm going to go ahead through it. So we're in 2.2, we're talking about friction. 2.1 I will have covered in class by the time you see this video. So friction is written as F sub F, and that's equal to the normal force times the friction coefficient. And you might be thinking, well, what are those things? He hasn't even covered them yet. Well, I'm doing this deliberately in this order. So the normal force times the friction coefficient. The friction coefficient is called mu, and that is a Greek symbol, the 12th Greek symbol in the Greek alphabet. They ran out of letters in the Roman alphabet, the ones that we use in English. So they went to Greek. Anyway, F of n is the normal force, and sorry about the handwriting there, but that is a normal force, and I'm going to tell you what that actually means in a moment. Just please bear with me. And mu is a frictional coefficient, and it has no units, and I'm going to show you why in a moment. Okay, the normal force, if you have gravity, we already know that gravity is pulling you downwards, pulls you down, and that is F, I'm going to call it F sub G is equal to mass times the gravitational pull, obviously. This has to be equal to it. So the normal force, so long as you're not sinking into the floor, so long as you're not levitating above the floor, these are equal, so that means that the normal force is equal to the gravitational force. So if you want to find the normal force in scenarios like we're going to see in 2.2, then just find this and you're solid gold. You can go from there and you'll know what to do. Okay, we're going to talk about Newton's second law very briefly. F is equal to ma. It's right here in orange. Oh, I thought, what just happened? Sorry, let me fix this. Darn it. I wanted to do this one error-free. Okay, F is equal to ma. That's Newton's second law. Force is equal to mass times acceleration. That's how I got into the trouble in the first place. Let me try again. Okay. That was supposed to be the highlighter, and I just crossed it out. All right. So F is equal to ma. That's Newton's second law. I'm going to go ahead and write the units and just tell you where Newtons came about, because the units for force is always in newtons. And if we talk about mass is equal to kilograms, as you know. And let's talk about acceleration. Acceleration is in meters per second squared. But it's just easier to write it in newtons, because this is the very definition of newtons, is kilograms times meters over second squared. So we're going to use newtons for force. Always use newtons for force. All right, anyway, the frictional force, which is F sub F, is equal to the normal force times the friction coefficient. And the reason why the friction coefficient doesn't have any units is because we've got the force, the frictional force, which is in newtons. It's in newtons, the frictional force, and the normal force is also in newtons. So, of course, those cancel out, and you're left with the friction coefficient, and there are no units left. So that's why it's unitless, if that's even a word. I'm pretty sure it might be. If not, it should be in the dictionary and become one. I encourage you to write a free body diagram whenever you encounter complex questions in physics. And this is an example of a free body diagram. So what we have is we have the normal force going up. That's pushing you up. That's opposing the force that's caused due to gravity, which is it's opposing mg. Where'd it go? Sorry, I'm really not good with this tablet. I'll get better over time. But it opposes it, so they're equal, and that's why you're not going in any direction vertically. So it's just holding you. So if you want to find the normal force, find the force due to gravity, multiply the mass times the gravity, and you're going to find the normal force. And also, the friction, when you draw these free body diagrams, we're going to be dealing with inclined planes and declining planes, and it's going to get more, and you're thinking, well, I can do this without drawing the diagram. I would get in the habit of doing it now because it's going to get more complex, I promise you, and these really make your life easier. And you'll be less error prone. The probability of you making an error if you have a free body diagram is much lower. So the frictional force is opposing whatever force is pulling an object forward. So this is pulling it forward. Okay. And if this overcomes this might be common sense, but if this overcomes this, then it will move forward. But let's say that the frictional force is higher than the object. Let's say you're trying to drag a 1,000 kilogram, I don't even know how much cars weigh, I'm trying to think, a 14,000 kilogram car across like 1 meter of snow or something. Of course, you're not going to be able to pull it. Friction is going to be much higher, and you won't be able to pull it, it'll stay still because friction is so high. Again, that might be obvious, but I'm just trying to kind of detail it to help you understand. All right, if it's constant and there's no acceleration, in other words, if it's not accelerating and the velocity is constant, then the frictional force is going to be the same as the force actually pulling the object. So if you see that it's at a constant velocity, they're the same. All right, so just set them equal to each other. You can break it down like I did here. Not that, so let me try again. All right, so you can break it down here, and then you can break it down further to be this, depending on what details they give you, what information they actually give you. So the normal force actually broke down to be mg, because normal force is the same as a gravitational force pulling an object downwards. All right, and then this, the horizontal force is equal to ma. Now, what I'm requesting you do is pause the video now, solve these problems, then push play. Number one is very straightforward. So you're just going to multiply the mass times gravity right here. Remember, we're using 9.81 for gravity in this curriculum, which is the American curriculum. So what is the maximum frictional force that must be overcome for the box to move? So if we exceed the frictional force that the force pulling is a frictional force, exceeds the frictional force rather than the box is going to move in the direction that it's being pulled. So we already have F is equal to Fn times the frictional coefficient, and we've got 147, and the frictional coefficient is given. We wind up with 58.9 newtons. 58.9 newtons. And then next is, if it's 60 newtons is greater than 58.9. So obviously, yes, it's going to go in that direction. So it's going to go in the horizontal direction that it's being pulled. So let's assume it's being pulled to the right, it's going to go to the right. And that's the end. Thank you.